Hello, geometry students. Mr. Zacek back and better than ever here. We're in the last lesson of Unit 5, and we're going to talk about inequalities in two triangles. And we're going to look at something that's called the Hinge Theorem. And the Hinge Theorem looks at when we have two triangles, and we know that two sides are congruent. The angle in between them tells us which side will be longer. So in this triangle we have a 90-degree angle. In this triangle we have a 70-degree angle. So therefore, because 90 is greater than 70, CK must be greater than YU. All right, since the two sides are there, we know that this relationship of not CK, excuse me, SK has to be greater than YU, because the 90-degree angle is opposite this side and the 70-degree angle is opposite that side. So SK is greater than YU. So if we look at number 2, it's another kind of hinge theorem. So hinge theorem. And hinge theorem, you can identify it when it's like side angle side. Okay, now they're not exactly the same. The sides are congruent. Okay, so you know, side congruent to a side congruent to a side, and the included angle. And that's the difference. So we look at these two and we see 125 is greater than 78. And so therefore the side opposite 125, which would be LM, side LM must be greater than side QO. Okay, again, nothing really, you know, it's not a really complex idea, it's just something we have to recognize. So the diagram below shows the position of a swing at two different times. As the speed of the swing ride increases, the angle between the chain and AB increases. Is the rider farther from point A at time 1 or at time 2? So what's happening here? Well, this is the same here. So AB is the same and BC is the same. It's just a matter of the angle that is the same. So is the rider farther from point A at time 1 or at time 2? So here's how we can explain this. Since the measure of angle 1 is less than the measure of angle 2, the rider will be farther away at time 2 because the angle is greater. So it's, you know, using the hinge theorem, the angle is greater in the second one. So as it speeds up, the length of the chain doesn't change, okay, but he gets further away from the ride. And that's something that we would, you know, just kind of intuitively know if you were observing that in person, but the hinge theorem helps explain it to us, okay? So when we think about this now, we look at what is the possible range of values for X. Okay, so we're asking what is the possible range of values for X? So we the challenge here is to recognize that we know two sides and we're looking at the included angle. So we know we know that RU is congruent to UT, and then obviously US is congruent to US. All right, and we are exploring the included angle. So what that needs to kind of trigger the thought process is, therefore, this is an example of the Hinge theorem. And we're flipping it around. We're taking the converse of it. So if we look at the sides that we have here, this side RS and then this side ST, we obviously recognize that RS is greater than ST. So as a result of that, the angle 60 degrees has to be greater than 5x minus 20. So if we solve that now, we can solve that for x. So 60 has to be greater than 5x minus 20. So if we were to add 20, we would get 80 is greater than 5x, and we divide by 5. Okay, so 16 would be greater than x. Okay, or if we just flip that around, x would have to be less than 16. So what is the possible range of values for x? It would have to be less than 16. So let's try that again here. In part B, same type of question, same type of setup, really trying to learn how do we recognize this. So again, we want to recognize that this is a kind of side angle side, so therefore this is a Hinge theorem question. And so we're looking at the opposite sides again. We've got 7, and over here we've got 9. So what's happening? Well, LM is going to be less than OP. Just the length, 7 is less than 9. So therefore the angle has to be smaller. So 3x plus 18 has to be less than 90. So if we subtract 18 from 90, we get 72. If we divide by 3, I think that is 24. So x would have to be less than 24 in that example. So those are the Hinge theorem questions. I think we've got them all there. And again, it's side angle side, and we're looking at the included angle, and we know something about that side. So that finishes up the lessons that we have here for Unit 5. We've got some assignments and labs and quizzes to finish up here for it. And then we'll be moving on. I'll be back on here with you as we start Unit 6. So good luck with your work. See you soon.